Hello customers and partners. My name is Steffen Wagner and I would like to explain to you how the Industrial Internet of Things can drive and support sustainability within the process industries. Sustainability is becoming more and more relevant every day, and it's become an integral part of our business. It's at the heart of our daily work activities to ensure we transform the everyday to create a better tomorrow. And there is a lot we can do using new technologies and the IIoT to drive sustainability forwards. The Siemens degree framework for sustainability focuses to fight the challenges of our times, but today I will be focusing only on one aspect of the framework, that is decarbonization. The basic idea of Siemens IIoT is a way for machines and sensors to pre-process data within industrial edge functionality, as well as to collect and send data to a platform like MindSphere to better carry out data analytics, support data-driven business models, and decision-making. But IIoT is not only about increasing the smartness and connectivity of devices. It's also about bringing more transparency to plants with regard to sustainability. Talking to our customers, there's a clear need for connected digital solutions that provide this transparency. Looking at trends for the process industry, we see many ways to leverage IIoT to reach for operational excellence and increase decarbonization. Many of these involve the complete value chain, aiming to extend asset lifetime and enhance efficiency for both plants and fleets. Other trends focus on reuse and recycle, maximizing the value of resources through plant and process optimization and predictive maintenance. One very specific way IoT can support decarbonization is to evaluate a product's carbon footprint. It's so-called PCF. And the PCF determines its climate impact. Calculating a PCF is done by looking at a product's entire life cycle, from its raw materials and manufacturing, transportation and use, all the way through the final product disposal. Manufacturing would include, for example, measuring what's needed to produce a product plastic housing. Transportation is logistics, focused and involve finding out how and how far a product is traveling. For example, it is being transported by ship or plane. And this is where we can start to leverage IIoT in the process industry. Use focused. This involves understanding how much and what type of energy is used during production, heated or cooled. So, where are we now? Can we perfectly and accurately calculate the PCF from cradle to the grave? The hard truth is that PCF information from within the supply chain is not transparent enough, and we do not yet have a solution that provides an overview of current sustainability indicators, or where we can see both the impact of future sustainability measures and solutions that drive the optimization of the production process. Notice that I said not yet. There are naturally obstacles in achieving accurate and actionable PCF data to drive sustainability and decarbonization within the process industries. The biggest challenge is to accurately collect and aggregate carbon footprint data, whether it's from a single switch or a compressor or an entire cabinet. Companies need to know their product and production carbon footprints in order to find levers to reducing greenhouse gas emissions. And when companies know their PCFs, it gives them the data to define, manage, and achieve their decarbonization goals. We also need ecosystems with open architecture, standardization, and common protocols to ensure we can access and share carbon footprint data for multiple vendors and suppliers and third-party devices. This would optimize both traceability and transparency and enhance the Global Reporting Initiative, an independent international organization that helps business and other organizations understand and communicate their impact with standards for sustainability reporting. And finally, we need to break down information silos to enable seamless onboarding, configuration and integration of PCFs. Importantly, PCFs and decarbonization involves much more than just hardware. Software is vital in allowing us to carry out extensive, structured analysis of industrial plants data, making PCF insights about our products possible. And with artificial intelligence, we can leverage sustainability-focused data in a way that was previously impossible. Imagine being able to collect, calculate, and then act on your product's carbon footprint using the same IIoT we are currently using to make your plants more automated and digitalized. As a result, the potential of using the connectivity of IIoT to make your production and processes smarter while driving sustainability is possible. In order for IIoT to effectively drive decarbonization, it's crucial to have a strong digital backbone with both an integration layer and vertical connectivity. This would ensure the breaking down of information silos and facilitate the seamless exchange and integration of data, thus giving us the carbon footprint data we need. A strong digital backbone enables predictive maintenance for field-level OT assets, performance monitoring for control-level OT assets, advanced process optimization, energy management, track and trace for product traceability, and inventory of logistics management. Let's focus for a moment on predictive maintenance for field-level assets because it's crucial to extend the lifetime of assets and reduce wear and tear. Asset Performance Suite is a plant asset management solution that collects, aggregates, and contextualizes data from different data sources using artificial intelligence, allowing it to be used for advanced data analytics. Working to preserve assets value with predictive maintenance, Asset Performance Suite, APS, provides you with an overview of your plants, indicating its current health status. It provides easy navigation across your fleets, plants, and assets with visually understandable data to help you to make better maintenance decisions. And its AI offers enhanced device lifecycle and optimization. So, using the power of IIoT and artificial intelligence together makes it easier to optimize your maintenance schedules to preserve your plant assets while also lowering your overall maintenance costs. And as APS connects and manages different data sources like engineering, process, and diagnostic data to leverage the hidden value contained in your data. APS can import existing engineering data and connect sources to give you a comprehensive overview of your assets. But imagine if APS could onboard product carbon footprint data to give you an overview of your assets' carbon footprint too. Thinking even further, imagine if Asset Performance Suite could also evaluate energy consumption patterns of your plant assets and use algorithms to make this data understandable for you. This would help bring us further towards transparent product and production carbon footprint data. With access to infinite data, the possibilities for driving sustainability are endless. Focusing on energy management and consumption within the water industry, it's also important, and this is where our SIWA, Siemens Water Application, come into play. It's understood that pumps are by far the largest electricity consumers within the water supply network, accounting for more than 70% of energy consumption. Our SIWA Optim application is a decision support system for optimized pump scheduling. It's a solution for the intelligent, energy-optimized control of pumps and valves based on the latest system data and demand forecast, as well as daily updated energy prices. It allows operators to reduce energy consumption by up to 15% while ensuring optimal security of supply. And the SIWA Optim Dynamics application minimizes energy consumption in drinking water distribution systems by using hydraulic modeling of the pump station to calculate the most efficient solution for transporting the drinking water. Energy is used to pump water during transport, fill storage tanks, and is also used to pump water from the storage tanks to consumers. Optimizing the operation of these pumps not only reduces energy consumption, but also reduces equipment stress. By providing continuous information on current filling levels, SIWA Optim Dynamics enables fast and targeted action in case of deviations from the predicted consumptions. It's also able to monitor pump condition through a specific algorithm that analyzes process data. This derives trends and recommendations for maintenance and operation to increase the availability and service life of the pumps and other components. Again, with access to infinite and intelligent data, the opportunities for reducing energy consumption are endless. Standardization is key to ensure we can connect and share data from the cradle to the grave to make it available and fully transparent, even from different suppliers or in different formats. The Industrial Digital Twin Association was founded in 2020 by VDMA, ZVI and 20 additional German industrial companies, including Siemens. And the core technology of this association is the Asset Administration Shell, which is a digital representation of a product containing asset information and functionalities. The goal of the AAS is to enable continuous data availability along the entire life cycle from the product planning and development, commissioning and production to disposal and recycling. This allows for the exchange of information between partners across the whole value chain. If the AAS becomes an accepted and implemented standard within the process industries, this could also contain the carbon footprint information of products. So as you can see, we need to find synergies between these new solutions to achieve our goals. A good example of this is joining together the analytic capabilities of Asset Performance Suite, the Asset Administration Shell, and our new application, the Industrial Information Hub. This Industrial Information Hub is a platform that empowers companies to access up-to-date technical documentation for their assets, connects manufacturers and plant operators, allowing them to share public and private documents, and helps technicians, engineers, asset managers to find all their required documentation in one place. Bringing these three solutions together, Asset Performance Suite, Industrial Information Hub, and the Asset Administration Shell, could provide an easy, seamless, and efficient information exchange between customers and vendors that aggregates data to enhance product carbon footprint transparency. So, what could the future of IIoT look like to further drive sustainability and decarbonization? Use connected and smart technologies to reduce the PCF of every asset as far as possible. Drive PCF transparency for the process industry and our customers. Establish one standard to share data seamlessly and easily. And finally, enable accessible data for the yearly Global Report Initiative for the transparency and accountability. We still have some way to go, but I believe we can reduce the environmental impact of production, increase energy efficiency, and move further towards carbon neutrality using the power of IIoT.